Here we have two simultaneous equations that we'd like to solve. You will notice though that equation 1 has x having a fractional coefficient. Some students find that a little difficult, so I'm going to show you a way to deal with that. Probably the best thing to do is to actually get rid of the fraction. So in this case we've got 5x on 2, the denominator is 2. So if we multiplied everything in equation 1 by 2, we'll remove the fraction. So let's do that. Equation 1 times by 2, that will give you 5x plus 2y equals 6, and I'll call that equation 3. We now have two simultaneous equations that you're used to looking at with no fractional coefficients. So now we can solve it using the process of elimination. Looking at the two equations, I think I'll get rid of the the value of y first. So the first thing we need to do is think what's going to be a common coefficient of y for both. And looking at 3 and 2 will make it 6. So it means equation 2 will need to be multiplied by 2. And that's going to give us 8x plus 6y equals 4. And I'll call that equation 4. And then equation 3 will need to multiply by 3. And that will give me 15x plus 6y equals 18. If you've done it correctly, you should now have both equations where y has the same coefficient. We do, so let's think how can we eliminate y. I think I'll do equation 5 minus equation 4. Write down what you intend to do. 15x minus 8x is 7x, 6y minus 6y is 0. 18 take away 4 equals 14. 7x equals 14. X equals 14 over 7 equals 2. We now grab that and substitute it into any one of these 5 equations. I'm going to use equation 2. So sub x equals 2 into equation 2, we get 4 times 2 because x was 2 plus 3y equals 2. 8 plus 3y equals 2. 3y equals 2 minus 8. 3y equals minus 6. Y equals minus 6 on 3, which is minus 2. So our solutions are x equals 2, y equals minus 2.